Okay, guys, so this is section 1.3, lecture number 2. So I'm going back to complex number system. And again, we continue with some of the theorems, which is very useful to know. So the next one, the next theorem is that the conjugate of the sum of two complex numbers equal the sum of their conjugate. So what that means? So I'm giving you here example z is equal a plus bi. So this is one complex number. The different complex number it's w, which is equal c plus di, because we know complex number has two parts, real and imaginary part. So if we want to take sum of the conjugate, the conjugate of the sum, so conjugate of z plus w, you can break it down as a conjugate of z plus conjugate of w. So how that theorem works in the real life, so let me give you the example. So example, let z equal 2 plus 3i. So this is one complex number, and w equal 4 plus 7i. 4 plus 7i. Okay, so this is what I want you to do. Find the conjugate of the sum z plus w. So using the formula, okay, we know that this is the same as conjugate of z plus conjugate of w. So z is 2 plus 3i, and we're going to take the conjugate. So we mentioned that a dash on top of it means that you have to take a conjugate. Plus w is the same as 4 plus 7i, and you need to take the conjugate of that. So conjugate of 2 plus 3i is 2 minus 3i, plus conjugate of 4 plus 7i is 4 minus 7i. And when you simplify, again, this one it's 2. It looks a little bit like z. And now you're just going to combine like terms. Real part, you're adding them together. So we have 2 plus 4, that will give you 6. And imaginary parts, you combine them together. So you have negative 3i minus 7i, that will give you negative 10i. So this is our final solution, 6 minus 10i. Also, I want you to let you know that if you will add the complex numbers together and then take the conjugate, you're still going to end up with the same solution. Okay. So that was one. Another theorem, which is useful to know, is the conjugate of the product of two complex numbers equals the product of their conjugates. Okay, so we have the conjugate of the product, z times w, again z and w are two complex numbers, is equal to the product of their conjugate. Okay, so this is another useful theorem. So let's just give you the example. So again, we have in parentheses 2 plus 3i, this is one complex number, times 4 plus 5i. So you need to find the conjugate of the product. So using that formula, I can break this down as a conjugate of the first complex number, which is 2 plus 3i, times conjugate of the second complex number, which is 4 plus 5i. And now we're going to simplify. So conjugate of 2 plus 3i is 2 minus 3i times conjugate of 4 plus 5i, it's 4 minus 5i. And now what you need to do, you just need to FOIL. So here we need to multiply that. We need to find the product, and we're going to do it by FOIL, multiply each by each. So that will give us 2 times 4, which is 8, 2 times negative 5i, which is negative 10i, then negative 3i times 4, which will give you negative 12i, and negative 3i times negative 5i, so 2 negatives gives you positive, we end up with 15, I times I square, okay? And by now, we know the deal. We know that I square has to be replaced with negative 1, okay? So let's simplify. We have 8, negative 10i minus 12i will give you negative 22i, plus 15, and I square will replace with negative 1. Let's simplify. So we have 8 minus 22i minus 15, which is the same as combined like terms, 8 minus 15, that will give us negative 7 minus 22i. So you always leave your answer in a standard form, which means real part first and then imaginary. Okay, next what we need to know the power of I. So this is another theorem, important. Powers of I, which is imaginary unit, follow a pattern. Okay, so hint, just to remember that pattern, the power of I repeat. It's like algorithm. Repeat with every fourth power. Okay, so this is how that looks like. Okay, so you guys want to know exactly the first 4 power. I to the power of 1, of course, it's equal I. I to a second power, we know this is negative 1. I to the third power is equal negative I. I to the fourth power is equal 1. And this one keeps repeating. Okay, how that keeps repeating? So look what happened. So the power of I repeats with every fourth power. So that means I to the fifth power will be I, like I to the first power. I to the sixth power will be equal negative 1. I to the seventh power will be equal negative I. And I to the eighth power will be equal 1. Okay, so what you need to know the first 4 powers, and then everything repeats, and so on. You can keep going. I to the 9th power will be I, okay, and so on. So let's do some problems. So what you may see on the test and also on your homework, problems like this. Example, evaluate powers of I. Okay, let's do 2 examples. A, you need to figure out what is I to the power of 28. So you're going to leave your solution. Okay, you're going to leave your solution as I, negative 1, negative I, or 1. So this is what we want to use. Okay, so we need to just use the information that the power of I repeat by every fourth power. So I to the power of 28. The worst scenario, yes, you can keep listing, follow that pattern until you get I to the power of 28, which again, I think it takes way too much time. So what we can do, we can break that power 28, and we know that 28, technically 28, is the product of 4 times 7. Okay, so using that information, you guys should know that when you multiply power of power, you can use that information that this is the same as I to the power of 4, and then everything to power of 7, because we're using the rule of exponents. So let's just review. Exponents. Let's say you have x to the power of n, and then to the power of m. When you have power of power, you're just multiplying those powers. So what I did, I rewrite that 4 times 7 as I to the power of 4, and then everything to the power of 7. So look what happened. We know what is I to the power of 4. Okay, I to the power of 4, it's equal -1. So we have -1. Oops. I'm sorry, +1. And then I still have that power 7. So now we know that 1 to the power of 7 is just 1. So I to the power of 28, it's 1. Okay, because it's multiple of 4 also. So if we know that I to the power of 4, it's 1, so 28 is the same as 7 times 4. Okay, so you want to use the rules of exponents a little bit to figure out the answers. Let's do B. You need to evaluate what is I to the power of 101. Okay, so here, what I'm going to do, I'm going to rewrite 101 as 100 plus 1. And when you're adding exponents, this is the same as I to the power of 100 times I to the power of 1. Okay, so on the side here, I'm going to review some rules of exponents. When you have x to the power of n times x to the power of m, this is the same as x to the power of n plus m. So what we had I to the power of 101. So 101 I rewrote as 100 plus 1. So using the rules of exponents, you can rewrite that as I to the power of 100 times I to the first power. And now, okay, 100 is multiple of 4, so from here you're going to get 1, but I want to show it, that you can rewrite that as I to the power of 4, and then everything to the power of 25. Okay, so I'm using that power of power property. 4 times 25 will give me that 100. Times I to the power of 1 is just I. And now I to the power of 4, it's 1. So we have 1 to the power of 25 times I, and 1 to the power of 25 is just 1 times I, and the answer will be I. So on the test, you really don't have to show me such a detailed work. Some of you may say, okay, 101, add number. Okay, if I to the power of 1, it's I. So most likely the answer will be I. I really want to explain it and review a little bit with you guys rules of exponents. If you see it right away, go ahead, put your final answer. I'm showing a little more detail because I want to review the exponents. So what you guys need to know that the power of I repeats with every fourth power. So definitely it's worth it to memorize the first 4 powers of I. Okay, so this is useful to memorize. Okay, next Here I review some rules of exponents. I gave you two properties. Let me just give you one more, which we're going to use it also, that when you have x to the power of n divided by x to the power of m, you can rewrite that. So when we have the same basis, different exponents, and we have to find the quotient, you can rewrite that as x. And when we have a division, you will be subtracting exponents. So that will be n minus m. So I just reviewed the three basic properties of exponents. And just one more. Anything to the power of 0 is always equal 1. Okay? It's good to review them. Okay, so a little more. Next, I want to give you the definition of principal square root. Principal square root of negative n is denoted by square root of negative n as square root of negative n equal square root of n I, and I is outside, okay? So don't forget that principal square root you only use in a complex number system. In a real number system, you cannot take the square root of negative number. So this one applies in complex number system, and let me give you the example. Square root of negative 3 in a real number system, something like that is undefined. However, in complex number system, so again, maybe let me just explain it. When you guys have all numbers, okay, which are exist. So what you have, okay, here, if I want to break it down, so here I'm going to give you the set. So this is complex number system. And inside of complex numbers, in the smaller sets are real number system. So don't forget that complex number system has that real part and imaginary part. So complex number system is bigger than the real number system. Not real, rational numbers. I'm sorry, rational numbers. Okay. So let's simplify that. So we have square root of negative 3 in complex number system. You can simplify that as a square root of 3 and you're putting I outside. And that's it. This is the principal square root. Okay, I just quickly want to prove it. You don't need to prove it. Let me show you. So square root of negative 3, you can rewrite that as square root of 3 times negative 1. And the square root of a product is equal the product of square root. So you can rewrite that as square root of 3 times square root of negative 1. And you guys know from definition that square root of negative 1 is just I. That's how we're getting square root of 3i. Okay. So Why are we learning that? Because we're going to solve quadratic equation in a complex number system, and we're going to use the principal square root. So, example, we're going to practice solving quadratic equations in the complex number system. So when you're solving equations in a complex number system, that's the one which you won't be able to factor using AC method. So use quadratic formula for them. So when you're getting that nasty solution, that means you won't be able to factor. Use quadratic formula. So let's just review that x is equal negative b plus minus square root b squared minus 4ac, that's the discriminant, and everything divided by 2 times a. So we're going to do two examples with solving quadratic equations in complex number system. The first one is x squared minus 4x plus 8 equals 0. So we're going to use the quadratic formula. A is the coefficient in front of x squared, which is 1. B, it's a coefficient in front of x, which is negative 4. C, it's always the number which stands by itself. So I'm going to use the quadratic formula. X is equal negative b. So negative b, we have negative of negative 4 plus minus square root b squared, which is negative 4 to a second power, minus 4 times a it's 1, times c, which is 8, and everything is going to be divided by 2 times a, which is 2 times 1. So slowly simplify, okay? So what we have here, we have negative of negative 4, this is just positive 4, plus minus, and let's simplify that expression under square root. So I'm going to show work here. So we have negative 4 to a second power minus 4 times 1 times 8. So that will give you 16 minus 32, right? And that will give you negative 16. Okay, so we end up here with negative 16. So that's the expression, that's the discriminant, okay, which I show work. So here we have negative 16 and everything over 2. So now we're going to use the principal square root, okay? So square root of negative 16 is the same as square root of 16i. And you guys know that the square root of 16 is 4, so we're getting 4i. Okay, so I use that principal definition of principal square root. Okay, when you have under square root negative number, keep only positive number under square root and I on a side. So I use the principal square root. So we end up with 4 plus minus 4i divided by 2. Sometimes the answer like this is correct. Of course, you always have to simplify. So in this case, each of the number can be reduced by 2. So you're just going to divide each of them by 2. So 4 divided by 2 will give you 2. 4i divided by 2, it's also 2. So you end up with 2 plus minus 2i. Many times we writing the solution that way, which we already know that we have two different solutions, but that's a shortcut. So you have to check how my MATLAB wants your solution, but we can write it that the first solution is 2 plus 2i. So like you see complex numbers, this is the solution complex number system, and the second solution is 2 minus 2i. Okay, so we got two solutions in complex number system. So a couple of things. How are you going to know that you have to do your work? Okay, you have to continue. So in the problem, when they ask you to find real solutions, we don't have real solution. But if they will ask you find all solutions, that means you're going to continue working and you're going to have the answer in complex number system. Okay, so here, if we work in complex number system, if they want the answer with I, the problem will ask you to find all solutions. That means we're going to focus on complex. If they ask for real, we don't have real. So again, we don't have real solutions. Okay, so that still apply because the number, the discriminant was negative, so there's no real solution. And I will do one more. B, we have quadratic equation x squared minus 6x plus 10 equals 0, and I'm asking you to find all solutions. Okay, so that means we're going to continue when, even if the number under square root is negative. So quadratic formula, a is equal 1, b is equal negative 6, c is equal 10. Going to use the quadratic formula, negative b plus minus square root of b squared minus 4ac, and everything divided by 2 times a. So negative b, negative of negative 6, plus minus. Under square root, we have b squared, which is negative 6 to a second power. All the time, when your number is negative, put it in parentheses when you have to bring it to the exponent. Minus 4 times a, which is 1, times c, which is 10, and everything divided by 2 times a. Okay, so let's simplify. So we have 2 negatives gives you plus, so we'll have 6 plus minus. Under square root, what we have, so again, let's just show work here. So you have negative 6 to a second power minus 4 times 1 times 10. That will give you 36 minus 40. That will give us negative 4. So we have negative 4 over 2. Now, here you guys know that the square root of negative 4 in complex number system, you're going to use the principal square root. This is the same as square root of 4i, and square root of 4 is just 2. So from here, we're getting 2i. So we have 6 plus minus 2i and everything divided by 2. And now I'm going to break this down. This is the same as 6 over 2 plus minus 2i divided by 2. And we're getting 3 plus minus I. Does that cancel? Okay, so we have two solutions. We have two solutions. In complex number system. And the first one is 3 plus I, and the second one is 3 minus I. Okay? And the same thing, when you see I, that means there is no real solution. So we have to get used to no real solution. Real means that's the numbers which you see, you can graph it. There's no way that you can graph it, you can see it. It's not really real. This is imaginary number. Okay, which was discovered by just continue solving, okay, problems. And just one note, and we done. That's it. So look what happened, guys. We got two solutions. When your solution of quadratic equation is in complex number system, we have, like in this case, 3 plus I and 3 minus I. In previous example, we end up with 2 plus 2i, 2 minus 2i. So hope you guys notice that those two solutions are conjugate of each other. So again, they are conjugates. Okay, so this is the note, the solutions are conjugate of each other. Maybe let me add it. The solutions of quadratic equations in complex number system are conjugates of each other. Okay, so again, this is only in complex number system, which means only works if discriminant which is the expression under square root b squared minus 4ac, it's negative. So when you have that, that means you will end up with two solutions in complex number system which are conjugate, and that always works. We got 3 plus I, so I know already that the second will be the conjugate, which is 3 minus I. Okay, so this is the end of section 1. Not 1.4, 1.3. I don't know why I'm thinking. Yes, this is section 1.3, lecture 2. So I'm going to post that video for you guys. Okay, so thank you for watching.